So, thank you everyone. Thank you for joining us for this exploratory tour of the ALSET data lake. We will tell you more about the data lake along with Dr. Teck Kiang, statistician at ALSET, and myself, I'm Alex. So you'll see how you can use the data lake and use it to improve your teaching or conduct educational research. Dr. Teck Kiang will demonstrate some data analytics using the data lake and focusing on the relation between field of studies and the career path of NUS alumni. He will also demonstrate how to use the data lake concretely and present some possibility to extract information from the data lake with just a few lines of code. We will then discuss some possible use of the data lake for other research and educational interventions. So stay tuned to learn more about the real potential of this unique resource that is the data lake. And I will tell you more now about ALSET and introduce you to our activities. So what is ALSET? The very acronym actually stands for Applied Learning Sciences and Educational Technologies. ALSET is an interdisciplinary institute, and we are collaborating with different faculty across different departments, academic departments at NUS. The institute has been created in 2016, and we are now working with a network of 80 affiliates. We are focusing on educational research and interventions in the classroom. ALSET is directed by Prof. Lach Samavedam, and Patricia Chen is acting as a deputy director. Patricia is also the research team lead on psychology of education, and her research focuses on self-regulation of learners. Prof. Jessica Pan is a research team lead on economics of education and look at the impact of studies on career. Prof. Joshua Goley is a sleep researcher at Duke NUS and also the research team lead on neuroscience of education. Then, as you can see, we are a small team of research fellows and research assistants managing activities for the center, for the institute, and supporting our affiliates. As a research center, an interdisciplinary research center at NUS, we are collaborating with many affiliates from different departments and coming from different disciplines. You can see here people from economics, biology, psychology, computer science, medicine, and so on. They are all affiliates, sometimes in research track, sometimes educator track, but they have a common interest on the learning and learning behaviors. They want to know how people learn, how to help them learn better, and how we can experiment some interventions in their classes. So what's in it for you? What can we do to help you? We can help you in 5 different main ways. First and foremost is the ALSET data lake. That is the very topic of today's seminar. We'll tell you more about this. We can also help you with your IRB application or the Learning Analytics Committee on Ethics, that is a DERC for research on education. And Dr. Teck Kiang, as a statistician, can also help you when designing your research or when analyzing the information that you collected from the data lake. We can help you with contacts and help you to meet other faculty to work with at NUS or out of the university. We can also connect you with the institutions to develop your own research. We provide some opportunity to communicate on your academic achievements through our seminar series, our newsletter, and our online communication channels, YouTube or Twitter, for instance. And finally, we can help you with your funding, either through some seed grant money from ALSET or to communicate on extramural grant opportunities and help you to meet some relevant partners to submit your proposal. So let's have a quick overview of the data lake before digging into the topic. What's the data lake? It's actually a way to bring together some data that is scattered across the university. The idea is to make all this data easily available in a single place with a simple access. So as you can see, the data lake is actually collecting and gathering some information from the registrar, the admissions, or the learning management system, the campus IT, the facilities management, or some information collected by researchers through their own research. And we are bringing together all this information for educational purposes. The data lake is evolving. It's something that is growing and evolving every month. At the moment, there are 70 tables in the data lake concerning 170,000 students and former students at NUS. As you can see on the left with the orange bubble, we have some information from the registrar, from the LMS, IVLE, and now Luminous, but also some external information from the GES, the Graduate Employment Survey, some other information on co-curricular activities, and so on. And as you can see on the right, with the gray bubble, we're also working on ingesting more information and considering bringing this data set in the data lake. Here, for instance, there are some main surveys that are ingested in the data lake. The Graduate Employment Survey that is circulated to every student in Singapore a few months after their graduation to know more about their employment status. There is the Orientation Camp Survey that is a survey circulated to students when they join NUS and gathering information on their motivation and their first impression of the university. That may answer the question in the chat panel. There is a freshman entry survey that was conducted in 2018, or some feedback from students on their module or on their instructors. So for each of these surveys, we have, of course, the questions that were asked, but also the answers and the information that were given. Teck Kiang will go further into detail using the Graduate Employment Survey, the GES. And as you can see here, in this kind of survey, we will have different sections addressing the background of students, their current employment activity, their job applications they went through before, their future studies they intend to pursue, and so on. Orientation Camp Survey on the right is another survey, and that can provide additional information on students, the faculties they are in, of course, their satisfaction, their motivation, and some other information on their demographics or their activity. So this is just some instance of what you can find in the data lake. And as you can see, there are plenty of information that can be actually also sensitive, such as the personal data on the left, focusing on gender, year of birth, marital status, and so. That is very variable for research, but of course we want to avoid any breach of confidentiality. This is why the information in the data lake is actually de-identified, and we use this system of student token that you can see in red on the slide in order to ensure connection between the different tables and enable some relation and analysis using this different table in relation with each other. And we provide access to this data lake after careful consideration of your research proposal by the Learning Analytics Committee on Ethics, and maybe the IRB if you want to publish afterwards. So we ensure this way, on the one hand, that the information is very interesting, useful for researchers, and on the other end, that it is still confidential and respects every rule on ethics and confidentiality. Among other tables, you can also find information on co-curricular activity, for instance, that can be linked to other activities, to performance in the class, some grades, or social background, for instance. Or some more technical data, such as the log on the learning management system, in order to assess when students connected to this system, to this platform, and ideally, what kind of action they actually did once connected, in order to see maybe what is the best time for students to connect, what is a good correlation to make between connection time and performance in the class. There are just some examples of the data tables that you can find in the data lake. And as mentioned earlier, this is a data set that keeps on growing and that we are expanding day after day. Here, our colleague, Kevin, is also the one managing this on a daily basis. And please feel free to reach out to us and contact him if you want to know more on the way to access the data lake later on. I will give the floor to Teck Kiang that will now explain more on data analytics and give you some example and a demonstration of the use of the data lake. As mentioned earlier, this presentation is recorded and you will have also the opportunity to go back to it on ALSET YouTube channel.
Yeah, thank you, Alex. Yeah, Alex have shared a review on the ALSET 70 tables that's so far have been created on the months of May 2020. And so move on to the next session to share with you with examples that is from extracted data analytic example that extracted from using the ADL, one of the tables called GES 2016, examine on the topics on the field of study mismatch. And then followed by a demonstration of how this is written in the Jupyter notebook to generate the data that is required by referring to the ADL. Yes, there are two files that is related to this particular survey. One is the survey questionnaires. The other one is the survey itself. And here they listed the file structure of the survey questionnaires. There are 3 variables here, and with 135 variables stored in these survey questionnaires. Yeah, so the survey questionnaire tables store the file structure. Here listed what is the question numbers, and the second column lists a short description of each of the question number, and the last column describe in full more detailed information about this particular variables. For example, the first line is question 1, which is faculty of the first major. The question 2 is the second major. If it is applicable, they'll be recorded here. Yeah, so for the survey itself, it's stored into another tables for this GES 2016. here listed the first 10 observation of 2 questions. The first question is on the first column, is column number 8, which record the first choice of the study as current course recorded, right? And the other question is question 35, will record a question that asks to these graduates about their choice of, about their field of study, right? And let me just give you some background information about this particular data analytics we have carried out. So what is field of study mismatch? Conceptually, it is if a student that study in law and upon their graduates, they join a job that is working as a lawyer or solicitor, we say their field of study match with their occupations. Yeah, the second example is accountancy. Graduates work as an accountant. If accountancy graduates work as a social workers, this is a field of study that is not matching with their jobs. Yeah, so same thing, if a lawyer, similarly, if a lawyer that works as a financial advisor, we're showing that it's not matching. Yeah, in these particular questions, we do not really examine the occupation titles with the field of study, but we ask directly to the graduates to say that is the nature of the present job related to your course of study of NUS. If their answer is yes, it is related to my field of study, then we classify them as matching. If they say it's partially related to the course of study, it is recoded as a partially match. Then if they employ in a job that's not related to the course of study, we say it is a mismatch of job. Yeah, in the ADL, the recoding probably will take some, we'll go through the demonstration with the R code. Here is just to show you what is expected from ADL to have some data management, and also can produce a graphical, quite colorful graphical tools using the package R that is available in the ADL. ADL come with 3 software. One is R, one is Python, the other one is Startup. So we are using R package as examples to illustrate how this software can be used to produce useful information for research and for teaching purposes. Yeah, so the output from the field study, the out from this question is shown as a pie chart here, to say that most of them are related, about 48.7%. However, partially related is about 31%, and graduates that respond that it is not related is about 20.3%. And if further breakdown by this field of study of these 3 variables of related to the field of study, by the opinion on the field of study after the working, we say thinking back, whether you think that you want to study back to the same field of study or not. The x-axis here is printed as match, mismatch, and partially match here. And total will add up to 100% for this 3 stack bar. The one that printed in green is they want to go back to the same field of study. In the blue one is saying that no, they are neutral about this. And painted in red is saying that no, they want to choose another field of study after they're working for a while. So you can see that for those that is working in a job that's matched with the field of study, most of them want to go back to, thinking back, they want to join back the same field of study. While for those that is mismatched, you can see a larger proportion that is prefer to change to another field study, while the partially matched group is somewhere in between these two groups. The stack bar do not show the proportions in terms of the numbers. So sometimes graphical output like Mosaic chart, which is the one that you've seen on the top right here, will show the proportions of the graduate respondents according to their frequency, right? So they produce similar output compared to the stacked bar chart, but they add in another additional information is the size of the proportions or the frequency. So you can see that from the match group is a larger proportion that's painted in blue colors to say that they want to stay in the same field study. The ADL also can produce from this survey to show what is the income earnings breakdown by faculty, because this monthly income information is available in this particular survey, right? You can see that the highest one is from the law faculty, followed by the medicine, then followed by the dentistry, and the lowest bar here is those that is graduated from the music, faculty of music. By comparing the average earnings for these three groups, you can see that there's an increment here. For those in the mismatch group will earn the lowest, followed by those working in a partially matched job, and the matched job in general will earn a higher income. And we also can generate models from when we use these data sets using the ADL. Yeah, so this is the result of generating two regression models by examining whether mismatch, whether they affect the graduates' initial income earnings. Because those that participate in the GES is a few months after they have graduated, so it's carried out at that particular time. Right? And for the first models, these two models is generated using OLS. OLS stands for ordinarily squared. And it include the mismatch where the reference is those that is matched. So it is a dummy variable, so it left to mismatch and the partial groups. And then it also lists down the 11 category of the faculty, while the reference group is the FASS. And the model to add in the gender to measure whether there's a gender effects or not. Yeah, from here we can see that those that is not in comparison to the match group, the log income, which is the dependent variable, show a negative sign here, means that the mismatch group and the partial group in general earn less than the match group. So similar findings can be found in model 2 as well. Yeah, so by referring to the blue box here is the faculty difference in their incomes. So those that is painted in, those that is indicated with 3 star means the p-value is 0.01, so as their statistical significance. So the two faculty science and multiple discipline groups actually is not statistical difference from the FASS in their monthly income earnings. And the model to show that the male actually is earning higher than the female. So there's a gender effects using these OLS models. And the OLS model is available in R. And R is a rather quite powerful package and to generate the models if you are using the ADL, and it's available in it. And because we are the next question is whether OLS actually have a good is good in modeling the by taking faculty into account, just using the dummy models. So the mixed effects model or the social sciences like to refer it to multi-levels, because the student is at the first level, where the student study in one faculty is grouped as the at the faculty level is the level 2 models. Yeah, so there are 4 models being presented here. The first model is what they call the null model, which is aimed to examine what is the variance partitions for the monthly income. The second models add in the mismatch and the gender. And the third models the third model is specifying to put the gender coefficient, which is normally just a one estimated coefficient, and put it into a random one. And the fourth model is further input the random effects for the mismatch variables. Yeah. So we just roughly explain what it is, and then we'll show it later in the demonstration and how that can be generated quite easily in ADL. Yeah. So for the first model is empty models. That's why it's called a null model. A null model do not have any explanatory variable, so there's blank over here. Yeah. And the variance is estimated for the intercept, and in this faculty intercept means at the faculty levels. The variance for the residue is referring to the students. So that is a variability generated by the models for the faculty, and that is variability generated for the students. So by comparing this, add these two together, and then divide the faculty to the sum of these two, we'll get 0.431. The technical terms that refer to is called intra-class correlation coefficients. We measure the variability of the monthly income earned by the students can be separated into two portions. One is the school faculty, the other one is the students. There to say that 73.1% of the variance of variation in the income actually comes from the faculty, and the rest of the 56.9 actually is due to the difference between the students. Yeah, so that is what is the function of the null models can generate. And the second models is we put in the two variables, the mismatch, match, and the gender. So it shows a negative size here, and both of them are significant. Means that those that is working in a job that is partially matched or mismatched actually earn substantially less, or rather statistically significantly less than those in the working in a matched job. And the coefficient here also show that the gender effects is there. That is to say, on general, the male is actually greater than the females in earnings, which is consistent with the OLLS regression models that is shown in the previous slide. But however, if we put in the gender as a random variable, that's to say that in fact we want to generate a set of coefficients by the faculty. Then this gender coefficients, the general effects, will turn out as non-significant. We'll show a graphical output in the next slides, right? To show these effects on generating using model 3 to measure the gender effects in a graphical form. So model 4, there's AIC and BIC are fixed indices to indicate whether the model 4, after adding the match and mismatch variance into it, to say that the match and mismatch actually vary by faculty. The AIC show there's a drop, and while the BIC show that there's a drop here, while the BIC show there's an increase, indicating that both giving some contradictory result on the fitness of model 4 in comparison to model 3. Yeah, so we have just went through the data analytic examples that's carried out. The data set is called using the GES 2016 is available in the in ADL. Then we'll now go through the demonstration of how these R codes are written in ADL, and how we can access to ADL actually quite not quite in a simple way. Right? So before we take a look at how at the R codes, we have to access by downloading the PAL security, so that by clicking on these icons, PAL security after installation, we'll get this particular screen. We click on the connect, then we key in our staff user ID and the password, and click sign in. Will turn the connect to disconnect, right? And then we can access to the ADL. So by doing this, we can go into a these particular websites to log on into the ADL, or rather log on to the Jupyter notebooks by specifying the username and the password, and click the sign in. Then we'll log into the Jupyter notebook here. So in Jupyter notebook, we'll show it shortly that you can create Python tree, R, or Stata, or you can even use a Stata GUI. Right now, we'll shift to another screen.
So I just see this opportunity to remind that this webinar is really focusing on the potential of the data lake, and further to some discussion in the chat panel. The very research is not actually the one that is put forward and for discussion. There are some ongoing research work that is more a demonstration, an example of some abilities of the data lake. We will address the question later on, but please keep in mind that this is really for the very purpose of the demonstration.
Yeah, so after we click on the Pulse Secured, it shows a tick sign here. So that means we already connected to pass the security. So when we click on the Jupyter notebook, we'll get this. So we can see that we can use either of these, any of these three software package to do that. So we can also create a folder because it's good for arrangement. Now we'll go into ADL webinar here, which is a folder is being created to generate the one that we just went through for the field study mismatch. Then after that, we have several files here. So we can click on the one that we just use it. We've just created that. Yep. So this is how it looks like. So, yeah. So you're arranging in boxes here. This is the command to read in files. So we can just put cell and we run the cell. Then you can see if it's running, you turn into black colors here. That it is running a R file here. Then you run the next section. Then we're saying that, this particular data set, which is a GES 2016, consists of 5,860 and 135 variables. You can see that it is very short syntax here. And then you generate the 10 observations, just now is shown on the slide here. And the other 10 observations of two selected variables and we go on to the next one. This is to tabulate the observations that is in the radiate response to this particular variables. Then the next one is to generate a pie chart. So you can see that it's quite fast, and also the syntax is not too long just to generate the pie chart here. So the next one is to run the cell, and we generate a bar chart here. So you can see that in fact you can just it can be all shortened without all this syntax if you do not want to put in the title and labels here. And the next one is to generate the Mosaic plot. Yeah, the demonstration to show you that how to use ADL and using the Jupyter notebook, which is work under the high performance computer. So you have a larger database to work on using ADL. That also could be possible, also can make quite easily because of the speed of the computing. Yeah, so we'll share with you to say that what are the possible data analytics could be carried out that will help you in your teaching and also probably research. So we'll start off with saying that in fact ADL can be used as a sampling frame to carry out your research. And ADL also can be used to carry out study directly using it. We'll use 4 examples here. And also ADL can be integrated to the survey you intend to carry out, and or some assessment you intend to carry out, and then you feed back to ADL to get more information. I shall go through some of these examples here. It's more like a suggestion to say that what are the possibilities that you can use ADL to carry out your research and to benefit for your teaching. Yeah, this is just suggestion. There are much more things that can be ADL. It depends on your research needs and also your research objective and what are teaching teaching observation that you want to get from ADL. Yeah, the first example's suggestion here is saying that ADL in fact can be a sampling frame. So there's an ADL here. Let's say you have some target students that you intend to study. Let's say the student that takes the second year economics subject and modules is your intended population. So in fact, we can get from ADL to put this, to retrieve information, to restrict information of what is the target populations that we intend to carry out. And we can do a random sampling because the frame is already there. Let's say you want to select 200 students to carry out a survey or assessment. So that can be done through ADL. And then after the survey, this survey information can feed back to ADL for further analysis, because you might carry out a survey or assessment in your semester 1. So once you have done the survey, you feed it back to ADL, the ADL will be updated, and then you can carry out more information, extract more information from that. Right? And before we carry out a survey or assessment by randomly selection from the ADL, in fact, we also can, based on past study, to get a feel of what we intend to carry out the survey. Is it that to get more information that what is expected from the survey or the assessment. Right? So we can actually do a preliminary analysis by looking at those modules we're interested in, and to examine, let's say, over the years, what are the modules, economics second year modules, how is the trend look like by extracting the information from the ADL. Let's say this is the trend of 6 years of the students, the number of students that takes all these modules. Yeah? So you can break down by faculty as well. Those that's taking this second year economic subject may not be students from the economic departments. So we can see the variation in the distribution of the students, where they come from. We can even go and link to some other data sets to have an understanding, to say that all these modules, second year modules, by linking to GES, we can in fact examine those students that is taking a specific module, let's say Foundation for Economics. There's a growth in the income, even though it's a different cohorts, but we can also, we can actually measure whether the growth for this module is compared to other modules for comparison. So, yeah. Let's say the Foundation for Econometrics, those that are taking these modules, in fact, there's a 12% growth compared for these two cohorts that graduated in 2015 and 2016. While in comparison to those students that are taking Economic of Modern China 1, that in fact there's a decrease in 3%. Right? Yeah. Touching on the same economics modules samples, we in fact can do further analysis beside the one you've just seen in the previous tables for comparing the modules in the growth in their income. We can identify from the module files or data set to extract information about the modules the years that we're interested in, to restrict the years, to get their marks. We can examine, can extract the marks, the grades, so we can further examine by their grades and marks, by tabulation the grades and marks over the years, and examine how the changes like. So the modules as the base, we can link to their personal file to get further information on their demographic, like gender, residency, their age, whether they live in the hostel. And you can further link to program and endowment to get which faculty they came from, and could probably link to pre-entry qualifications files to get pre-entry informations, or let's say the year they award in graduates from, let's say, JC or some other college, when they have graduated. So we will know that whether they have stopped working for a while before they join NUS, or just freshly from A-level, they strictly join NUS. We can even join the CCA to get the information about how many CCA activities they have participated in, and can link to GES about their money income, which we produce tables here. Yeah, so that's another table that is generated to reflect by the modules. What is the average CCA that the students that enroll for this particular modules, the average number of CCAs they participated in. So the highest here is those that is taking the business, the economic analysis of business module. The lowest here is the one that is take the modules on the economics of modern China. Right? Yeah, and we can examine by gender to see that what is the average gender on the dotted lines, and the one that is there are more male than female that's taking this course, which is the quantitative course on the economic analysis of business. Yeah. So in short, a research study can be carried out, and research study and analysis can be carried out just purely based on ADL. So it depends on the research objective. Not only that, we can also understand the student progression if the student, the information that we want to extract from ADL, it is stored in the longitudinary format. We can also do some data management to include this data. The models here is generated using the 6 module of chemistry laboratory modules that the student have taking over their 3 years undergrad period with NUS. So because the same student is measured over the 3 years period, so it is a longitudinal data analysis that we can carry out. Being the student taking, let's say, year 1 of 1 experiment, year 2 probably another 2, year 3 for another 3, that is subsumed under the one student. Then it go all the way to the student that's taking for the 3 years period. I'm sorry, the 3420 is the arbitrary one, does not reflect the study over here, right? Yeah, and so we can build in using the mixed effects model as well. Let's say we fix an unconditional growth model, to saying that the grades that the student attain, which depends on the initial grades plus the growth rate over time. We'll put in the time variable here that is varied by the students. We also want to see whether the initial grades is varied or not. So we put in a random components, random variation here. Then whether the growth in their grades, we also put in a variability component here. So we can in fact examine what is the variability of the initial grades and also the variability in their growth. And that is the estimated models. And we can see that the relationship between initial grades and the growth is actually a negative one of 0.71. That is to say the initial growth rate is low, the growth rate will be higher, while the initial grade is high, the growth rate is actually much slower, right? And the intracorrelation is about 0.33547. That's the variation in grades mostly is from time, rather between the students, which consists of 64 about time, about 35 in the variation in the grades is due to student differences. We also can carry out quantile regression. We can plot the lines by quantiles to say that those that is low actually grow faster, and those that is high actually the slope is much lower. And I mean, another graphical form is putting the quantiles on the x-axis and the grades on the y-axis, and that is the initial grading varied by quantiles and the initial grading by slope. So you can see that their relationship is these two variables, the initial and the growth, are negatively related. Not only that, we can use to carry out longitudinal data analysis based on the historical data that is available in ADL. We can probably use some statistical methods to use ADLs, because ADL consists a lot of records, so that we can use certain statistical techniques like the one that is mentioning here, called propensity score analysis, to use this particular technique to carry out something like close to an experimental design context. We want those that have interested in randomized controlled trial could refer to probably Fisher's first advocated that, let's say we can randomly assign, let's say those as taking language class and those are not taking language class, to do a randomized control trial. And alternatively, we can use ADL as well. ADL, the propensity score analysis, in fact, it is a matching mechanism that's behind it. That's to say that instead of have to have one in the language class, another one male in the language class, one female here and one female here, and those is local here and those is local here, then we'll run into what we call the curse of the dimensionality, because there are too many variables that we have to control for in order to place a match person that is put into the language class and those that's not taking the language class. So putting all these covariates into one score, we call the propensity score, and use those propensity score, that is, those students have a very close propensity score, and then put them into those that's attending and not attending. Then we can actually select students that is very comparable into these two groups. And then it depends on the outcome that we want. Then we can, let's say if the grades is the outcome, the performance score is the outcome, then we compare the performance score of those attending the language class and those that is not attending any class after we select those as comparable in their propensity score into these two groups. Yeah? So another suggestion is that we can use other type of, here is just mentioning two statistical technique. The one that we just mentioned, it is propensity score analysis. Another possible way is sequence analysis. But it's, I mean, ADL can use quite a lot of things that you can use because the data set is big. This is just two examples to suggested to say possible way of using ADL in a more effective way to carry out your research, right? Yeah, so a sequence analysis is one way that we can, if there is a lot of data points that is there, and we can put them in the sequence format to examine student learning's pattern. Yeah, so if we can, here is one student, here is one student, that's another student. We can access to what is the student learning pattern by going into IVLE. so that to capture what they click on, as what Alex had went through the data file that we have. Similarly, the online access pattern, when they log in, how long they log in, we can also examine the pattern as well. If then the patterns of one student to the next students is recorded, then we can examine how similar of this sequence compared to the next sequence of the students. Then we measured them by using what we call optimal matching. We said this sequence is very similar to this sequence. Then we say they are very similar. Then the student 1 and student 2 will be measured into a distant measures to see that how similar are they, and put into a matrix form. Let's say if there are 5,000 students or rather 500 students you're measuring for a specific FASS, then we can see what is how similar is the first to the second student about the sequence of learning, and the first to the third, and so on to the first to the 500, and so on. And we have a 500 times 500 matrix there. Yeah, so the sequence analysis is originated from a biological world. They want to compare the sequence of the RNA or DNA, or to have a taxonomy on the animals and or birds, or to come up with a taxonomy to say how similar are they. Yeah, so that can be also applied. The sequence analysis could be applied in ADL once there's a sequence of learnings being captured there. Yeah, so just to go through what is the expected things that if you are using sequence analysis, using optimal matching to match the students. Once you have a distant matrix, then we can do classifications on the students using some classification techniques such as cluster analysis. Let's say after the sequencing, we classify into 3 groups of different learning pattern, then we can carry out analysis as well to, let's say, multi-normal regression analysis. So if there are 3 groups, so we'll put down the 3 groups here. You say that, oh, how does it differ by listing a list of covariates? Let's say more male would be going for the first learning pattern, but less for the second groups. And we can have a list of covariates, explain why there are 3 types of learning sequence there. In reverse, that to say that we can also put let's say we have 3 sequences that's quite unique in it, and quite different between them. Then we can also put this sequence to explain something like the academic outcome. So the output from the sequence analysis now turning from dependent to the independent variables to explain certain academic outcomes as well. So that is also possible. And not only that, we can use directly from ADS. This is what have done by Joshua, our team lead, that carry out the Sleep Habits Survey 2019, which you have said, I think, quite a couple of weeks ago, about he feedback the sleep habits survey into ADL. His feedback is into ADL, and then he makes use of other information in ADL and to come up with further analysis to say that whether a person that is earlier bird sleep or night sleep, will it affects their learning patterns. So in short, there's to say that survey that carry out could be integrated into ADL to get more information which is not available in the survey. So during the design stage of the survey, in fact, you can build in what is already available in ADL. So you know to capture, then those that is crucial, that is not inside ADL, then you ask directly from the respondent. Similarly, assessment also could be carried out, not only surveys. We can carry out assessment, and then the result of the assessment can put into ADL, and then we carry out further analysis. This is just to illustrate the examples that that could be done through assessment and modeling to examine students' skill learning. And then the result of the assessment can be linked to ADL for further analysis. Just to briefly describe what is connective diagnostic models. First, the instructor will, let's say they will select 200 students, and then they set up a 20-item assessment. Then this assessment, after carrying out, we were able to identify what are the skills that whether the student learn about, whether they master the skill. That is to say, the 20 items of the item being designed, these 20 items were unable the student to learn 8 skills. It's represented by alpha 1 to alpha 8 here. Yeah. So probably some of let's say item 1 and item 1 were is testing on the student whether they master the skill of alpha 1 and alpha 3. Then item 2 is alpha 1 and alpha 4. Then item 20 is about 1, 2, 3, and 4. So by designing this, then going through the modeling called connective diagnostic models, will be able to know that what is the probability of the student that participated in this assessment, what is the probability of they mastering the skill for 1 to 8. So similarly, we can also the models take into account of the guessing and non-slipping, 2 basic components in the account. A person can guess to get a correct answer for the 20 items here, yet in fact he have not mastered the skill. And on the other way, he can get a wrong answer because due to some reasons or others, just slip of the mind and then did not concentrate on answering the particular question, then he get a wrong answer. So this is what the connective diagnostic models built into to examine whether the student had mastered the skill. And the relationship of skill is also tabulated, could be tabulated from these models. And the pattern also could be examined to say those out of 200 students, 154 students actually get all correct. And there's one incorrect here for the third skill, is 18 of them, and so on and so forth. Yeah. So this has been applied in the in primary school. A paper that published quite some time ago is about subtraction of fraction. So because subtraction of fraction is a concept or is a mathematical area that is more difficult for the primary school students. So at the end of it, after they went through the connective diagnostic model, in fact, they can give individual students about which one they are weak at and which one they are strong at. Let's say the report actually is that subtraction numerator, you're good in it, but the finding of common denominator, you're weak in it, and separation of whole number from the fraction is somewhere in between. Yeah, so that is one way of how you can use some modeling technique, and then after carrying out, feedback to ADL, and you can extract more information from it. The last one, after going through a demonstration, after suggest some of the data analytics, so we really like to hear from you what are the things that you can work with us to come up with more research projects, access to ADL, get more information that's helpful for teaching, and also to carry out research projects. So we attach some references for the one is the package RODBS. The ODBS is the database that when you're using R that link you to the data tables reside in ADL. So that is a reference for that. And we also attach an introduction to R because some of you may not be familiar with R. So there's a this documentation will provide you a reference note to start using R. Divide into the 3 sections. One is the introduction to R within this particular PDF file, and some how to generate descriptive statistics, and how to generate graphics using R. And the last one is ADL data management. Well, the access to ADL, probably you need to do some basic data management. This document essentially provides how to write files, how to create, how to carry out data management, how to create new variables, and how to rename the variables, how to shape the data, let's say from a short format to a long format, so you can carry out longitudinal data analysis, and also how to generate descriptive statistics using some summary function that is available in R. Yeah, I think that this is the website that is, you can download the reference and also the slide, and do visit our websites, and also do write to us, do keep in touch with us to say that what is the idea, how to access the ADL. You can contact Alex, you can contact Calvin or myself. And Calvin is the one in charge of the database here. He'll tell you more about this. If you contact him, then you tell what are the things that is developing in ADL and what is available. And for approval to access to ADL, Calvin will be the one that will serve you, right? So I think I'll stop here.
Okay. Well, thank you very much, Teck Kiang. Thank you for this broad overview of the data lake. Just before jumping into the Q&A session, I'd just like to stress on again that this is indeed a quick overview of the tables available in the data lake and what can be done with this information. We showed a few tables earlier in the presentation. You can also read more on our website, and if you want really more details on the available tables and fields, please write to us, especially to Kevin, our colleague Kevin Hartman. I mentioned his email address in the chat panel, and you can also find it on our website. You will then be able to have more detail on the catalog, the data catalog, with the kind of information we have and how long that can go back in time. Another word of conclusion that was also mentioned by our director, Prof. Laksh. We are welcoming every NUS teaching community to make good use of the data lake for your research, for analyzing your teaching. And this is also a great added value to use in your grant application. We have the opportunity to use this data, and that can make a real difference when you are submitting a proposal to use this innovative data set that is quite unique in Singapore. And finally, as my colleague Kevin also mentioned, the more the merrier. And when we are asking access to some data set, well, of course, we need to get approval from the data steward. We are not collecting the data in back of any colleagues. And NUSIT is also asking for the use of this data. And the more people will use it, the more researchers will be using this data set, the easier and the faster it will be to get the data set ingested in the data lake. So I have posted the address of the web page where you will be able to download the slides, download some references, and later on to get access to the video. And we can now address some of the questions that we received. So maybe Teck Kiang, you want to provide also some information, and Laksh and Kevin in the audience are also, of course, welcome to join. So the first question came from Florence Ling and wanted to know about the available data in the graduate employment survey and how recent information we have actually.
The GES, the 2015 and 2016 is already available in the ADL.
I think we are also working on ingesting the last data sets. Of course, it requires a lot of data cleaning before ingesting data. The fields are not always the same. The ways that they are encoded also are not the same. For instance, female can be used 1 year and the year after that will be just F or 2 to code female respondent. So there are some issues that we have to deal with before, and Kevin and his team are actually very busy with this kind of data cleaning as well.
For survey data sets, probably they're quite, I think before they put in the data cleaning will be done by the department that, let's say GES, they've done some cleaning before they actually uploaded, I think, to ADL. Yeah, so if you're working just on the survey data set, probably they can be analyzed in standalone. But probably you want to get more information, that's why the GES data set will be linked to some other data tables as well.
And we had some other question in the same field about the kind of data sets that are routinely collected by the data lake, such as module feedback, student life survey, and so on. So we provided some answer in the chat panel, but maybe we want to respond again to this one. What kind of data tables are actually collected on a regularly basis?
I think, let's say the student data, if I'm not wrong, Kelvin, if you can point to me if I answer not in yeah. I think is adding in year by year, or rather is periodically you'll be adding in from a certain period, I think from 2005 on, right? Yeah, so they'll be updated, let's say personal data, program enrollment, all these will be added in when the times rise. Yeah. And I think there's one question here, it's about the pre-entry qualification that using longitudinal study. I think the question is not so much whether A-level and poly results and or UAS score available as well. I think the thing is that because all these are, I think, probably available, if I'm not wrong. But the thing is that whether if you are measured in a longitudinary way, then certain adjustment may need to be addressed in order to have a comparable, let's say if you want to measure growth, longitudinal data analysis is more on the methodology issues rather than the availability, I think. I hope I answer Ralph Phillips' questions. Ralph Phillips, Anthony, yes.
So there were some other questions related to your field of study mismatch. I don't know if this is actually really needed to go into detail with that, since we are trying to focus more on the data lake.
I'm sorry.
So we have Alberto Sarvo who asked about the student demographics available.
Yes.
So you may want to say more about this kind of information.
Yeah, so let's say if the personal data will consist of let's say gender, age, marital status, country, residence, if they're working organization, what's the job title, whether they're returning from NS, whether it's special needs and all that. Let's say if it is program enrollment, they'll be concentrated on what type of programs, which faculty, which departments, the terms they start, the terms they end. Let's say if it is module, then is more focusing on the modules they enroll, what are the courses, what is the grading, what is the marks, what is the basis of the grading, and so on. So so it depends. Let's say if it's a leave of absence, they also capture student leave of absence. Then if they have external test score, they also capture in external test score. And yeah.
Maybe we can add that access to the data lake, as mentioned earlier, is also conditioned to the pre-review of your project, and access to each different table or field is also needs to be approved by the Committee on Ethics and maybe the IRB, depending on your research plan. And some information sometimes may not be necessary for the research, and so we won't provide everyone with sensitive information such as zip code. Sometimes we are actually able to give information that is a bit more general, that will give information on the neighborhood of the students rather than the exact same code, zip code that is actually very detailed in Singapore, as you know. So this is something that may need to be stressed as well. And the other one is that we are also collecting, some of the researchers are, of course, collecting additional information through their own research and their survey, for instance. And that is an opportunity, of course, for them to match it with what is available in the data lake. And later on, if they agree to, that can be used by other researchers for later research as well, and then provide more demographics, more information on students as well.
Yeah, maybe to add to Alex, because if you carry out a very recent survey, and you when you integrate into ADL, you are the one that will give the access to whether who can access to your survey, because you have not the exhaust of what you intend to publish from the survey. So that's to say that you can access, upload to the survey and link to all, but after you think that there are certain stage that then you can share your survey to the rest of the faculty's members that to link your survey to their own information that is uploaded. So there's a plenty of coordination work that is also possible from faculty to faculty to come up with new research publications. Once you know that this sort of information is there, and then it matches well between you all, then you can come together to work and then explore more using the ADL.
Is there any other questions that we need to address now?
There's another question from Bing Key saying that, is it possible to share the data dictionary for each data set first so that we can study how to combine? I think the data dictionary is there, right? Yeah, there's a data dictionary there. But you must apply to Calvin. Calvin will after you'll be able to access to the data catalog. We call it the data catalog.
So once again, the most important regarding, for instance, student mobility data that Ruben suggested, we are indeed, we may have to collaborate more with some data stewards in order to get access to this kind of data. And as mentioned earlier, the more people will be actually interested in using this data, and the easier it will be to build and develop the data lake in order to get more useful data sets in the data lake. So this is a kind of a chicken and an egg problem, but we've been beyond already, and we managed to build something that is already very useful with many tables. And the more we will use it, and the more useful it will become as well. Well, thank you, Alberto, for your kind comment. We are indeed working for the greater good and for the whole university. You can access to this data lake just upon request based on your proposal and the academic relevance of your request. So feel free to contact us, to email us, and we can meet and tell you more about what's in the data lake, discuss your project, and you can pick our brain in order to see how the data lake will be useful to you, or ALSET in general. So please do not hesitate to reach out to us. This is our very purpose indeed. Well, if we don't have more questions, I suggest that we move to our next activity in the schedule, and we'll thank you again, and please visit our website to get the information, the slides, and the video. Good, Teck Kiang. Thank you. Thanks, everyone.
Okay, thank you, everyone.